Perfect. I'm gonna close this up for now. All right. Containers. We're a little ahead of schedule. This is great. One more chance. You've all installed Docker and or Podman, right? We all have it. Great. All right. Let's talk a little bit about why we're using containers or how we could use containers. Our computers are unique. You know, like they say that snowflakes are unique. I think actually computers are more unique because we each have like installed a different configuration of software, whether we did it intentionally or overnight, our computer did an update. We all have very unique, if these are all different softwares that we installed, we all have particular software packages installed and particular versions of those software packages installed, depending on when we installed them. And obviously, like we've talked about how Chime 2 has their releases, all these other software packages we're using have their own release schedules and updates. And it's impossible to find two computers that are exactly alike. Well, ones that have been used, I suppose. And yeah, they change over time. And sometimes you don't even know that they're changing. It just installed an update without you. And so here's an example of a thing called the session info. This is from R, but obviously Python and other things can print out session info for you. And it's just kind of the reason that this is handy for reproducibility purposes is that it can tell us about the current computing environment that we're working in. So what software packages are attached, what are installed, what versions of those things are installed. And so like here's two to compare from. Like I ran the same analysis in two different things. One was in different operating system. So this was in Mac, this is in Ubuntu. This is different R versions. There's different R Markdown versions. There's different packages loaded. So there's a lot of things that can vary. And this is important. I actually referenced this paper yesterday, but here's the actual paper at the very bottom, although you might not be able, oh, you can see it on the recording, but not on the screen. Let me move my, so you can see it's, no, I have to move it here? No. Okay, I'm not gonna worry about it, but it is in the slides that this is Casey Green and Below Jones. I don't know if I'm saying his name right, but the point is that computing environments do in fact affect analysis results. So they did the same analysis on different machines and they would get different numbers of significant genes. So that is a thing we need to be concerned with. But if we try to get two computers to be the same, we could spend so much time. There's literally, they call this dependency hell, where you're trying to install things, but those things are dependent on other things, and those things are, and then you just get in this vortex. And I'm sure anyone who's tried to install anything, perhaps it was Docker for you, you may have gotten into this frustrating spiral. Okay, that's also frustrating. And like, yeah, we could buy a bunch of laptops to be reproducible and ship them to our collaborators so they can reproduce the analysis, but that's just not a feasible solution money-wise or time-wise. So containers can be a solution. They're kind of like your computer is running a different computer inside of it. It has a disguise. It's pretending it's a different computer within the inside of it. This is a very vague way of describing it. If you could describe it this way to a computer scientist, they might get upset with you. But this is an intuitive way to describe this. So that means in that scenario, if this researcher has a particular computing environment, they could easily ship that to their associate. And by ship, I just mean like they could send it on the internet. Nobody has to send any computers anywhere. And then they could know that their colleague has the exact same computing environment if they're using that same container that they shared with them. That's awesome for reproducibility purposes. It's awesome for avoiding installation headaches for all kinds of reasons. And in that same paper, they show that that's a very reliable way to do this, that you can indeed get the same results if you have the same computing environment. So it's taking one variable out of reproducibility. So just to recap, here's top reasons for using containers. There's probably more reasons, but here's some good ones. It helps with reproducibility. It helps for easy sharing with your collaborators. You can avoid installation problems. Yes, I know we made you install a hard thing, but at least you only had to install that one hard thing and not 100 other medium hard things. So that's something. Now you don't have to go back to IT every time you need to install an additional software package. And it can be really handy for testing. Sometimes when I'm doing an analysis, I'll be like, is this different because of the software packages or because of something else? And being able to isolate the variables as scientists, that's important to us. And containers allow us to do that for computational analyses. So this is how I think of images. So images are what we can share with folks, okay? And when we run an image, it can become a container where we can now play and do stuff. And so if you've seen Mary Poppins, if you've not, I don't think it's a spoiler if the movie's like 70 years old, but they kind of jump into the chalk and it becomes a whole world. And that is how I think of Docker containers, is that you have an image that might be kind of flat and easy to ship. And then when you do Docker run or Podman run, then it can become a container where we can run things and know that it's isolated. It's an isolated environment. And so it kind of can look like this. This is like another schematic to kind of describe this. You have an image and you take like a snapshot. That snapshot is shareable. And now when you share it with somebody else, they can build that container from that image. There's options. I should honestly have put Podman on here too. But Docker Singularity is the version that is a little more security conscious, I guess I would say. It's now being called Apptainer. You can use both. You can use these interchangeably. As you can tell, you can also use Podman mostly interchangeably. So people are doing a pretty good job at trying to make sure that all these containers are friendly with each other, which is great for our purposes. Okay, sorry. That was enough lecturing. Let's do container things. All right. So the instructions and the files can be found here. Actually, don't worry about that. I'm going to actually link you to the specific instructions in a second. Yes, there's a question. What is it? Clusters? Clusters are different. So you could run. So yesterday we talked about shared computing, right? That's where clusters are, where you have like a whole bunch of computers somewhere. Those are physical computers. A container is an environment on a computer. So I could run, for example, a container on a cluster, or I could run a container on my computer here or there. Like a computing cluster is a place that has a service. Like we can go pay for that computing service. It's somewhere physically located, where a container is a computing image or environment that we can share with people. It's not so much a physical computer itself. Does that make sense? Did that answer your question? Okay. Before we jump into the activity, a little note about window juggling. I think sometimes I can get very comfortable with window juggling because I do this a fair amount of where we're working with like 4 or 5 different apps and gets a little, crazy. And so I just want to give a preface about different apps that we're going to be juggling with today, that we kind of have to do a keeping all of these tabs or windows open at the same time, because we're going to need to reference them again. Okay, so Docker is one of our key players. We're going to be using Docker or Podman. Okay, Podman, unfortunately, doesn't have a GUI, so you won't have the nice buttons you can click with desktop, but that's okay. We'll also be using Terminal or Command Prompt. Okay, that's where we're going to be putting in some things as well. All right, that's a second player. We have Docker, we got Terminal, we got a text editor. It honestly can be the text editor of your choice. I don't care which one, just could be the default, but we'll be using that too. And then obviously we have these slides. For your convenience, I've put the instructions on a website so you don't have to reference the slides, and you can just kind of have the slides in front of you while you look at the website. So that part is a little bit eliminated, but just so you know. Okay, so here's where the instructions are. So if you have Docker, go to the first one. That's bit.ly Docker1. Or if you're using Podman, I need you to go to the Podman instructions over there. So I'm going to actually exit out of presentation mode, and I'm going to be doing this with you. Minimize this a little bit. All right. So we're already window juggling. See, I minimized my windows. We're about to juggle some windows. Okay. So bit.ly/Docker-1, and it should bring you to something that looks like this. Okay. How do we follow along with this? The way we do it is, first of all, you'll notice that if you ever get lost, I have the headers of these steps. They're going to be the exact same as in the slides. So if at some point, well, there's some extra slides in there too. If you don't see it line up, that's just because it's an extra thing. So you'll see step 1 Docker pull, step 1 Docker pull. So if you ever get lost, you can look at the table of contents on the slide and hopefully jump to where we are. Okay. The other thing that can help you follow along is that we have checkboxes. So I encourage you to use the checkboxes as you do each step because it's going to be very important to do these steps in order. If you've done enough computational things, and we did some yesterday, you'll know that the sequence of things is important. Okay, so getting started. First of all, let's back up. We'll go back to the slides. I'm going to have the slides out, but honestly, I would encourage you mostly to keep the website next to you, okay? You can certainly keep, I'm not going to, you could keep the slides open, but all right. So activity zero, activity zero, activity zero. That's where we're starting, getting started with Docker. All right, you have all done this step. Great job. We can check this box. We've installed Docker. You can create your Docker account if you don't have one. We won't actually be using it very much today. So if you haven't done that, you actually can let that go for today. That's okay. And then after you install Docker, we need to start up Docker by double clicking on the app. So I'm going to start my own Docker app. I'm going to search for it. And there, I see it right there. So start up Docker. If you are in Podman, I'm now switching to Podman just to show these folks because this step is a key difference. You are going to actually, instead of starting up, oh, get out of here, Docker. Hopefully you've installed Podman, but then what you're going to do is in your terminal, you're going to run Podman machine init and Podman machine start. Okay. I am going to be doing Docker, but if you are using Podman, that's what you're going to do. Okay, great. So we have Docker running or Podman. Everyone's got Docker or Podman running. Yes, some nods. Great. All right. The other thing we need to do before we start is we need to download a zip file of the workshop files that we're going to be using. So you can find that in here. I think I realized I didn't put the link in the Docker instructions, which is unfortunate. So I got to edit that. But you can find those in the slides as well, or on the Podman ones. That's the very first thing. So we're going to go here. This is on GitHub. Okay, notice I'm keeping my website open. I got my slides open. I know we're starting to do window juggling. We'll be okay. And then we're going to click this big old green button. I'm going to click download zip. Okay, so I'm going to pause on this screen for just a second. We all need to get these workshop slides. So click download zip. I'm going to do download zip. And you're going to want to keep track of where your particular computer, because it's a snowflake and does its own thing, is going to download the workshop files. You see mine, I actually have it downloading to the desktop, but okay. So go to this website, download zip. This is the website. It's GitHub. We're going to talk more about GitHub tomorrow, but download zip. I'm going to pause here. I want to make sure everyone has these files. So all right. How are we doing? Why don't you just give me a thumbs up? I'm going to drink a sip of coffee while you all download these zip files. Zip file. Thank you. Okay. Can I see some like thumbs up or nods of people who have downloaded the workshop files? Okay. Seeing a lot of people are getting there. Do you have a question or you got it? Okay, great. Okay. I think we're almost there. Anybody having trouble? if you do have your files downloaded, you can double click or right click to unzip them. So sometimes on Windows they'll say uncompress or decompress. On a Mac, you can generally double click and it's gonna unzip those files for you. Okay. So if you have yours downloaded, download zip like this, clicking this button, it's a green button, down like that, find where it's downloaded, and then either right click or double click, depending, and you'll have those workshop files. All right. Yes, sorry, and I can also show it better on GitHub, but it's FHDSL/containers for scientists sandbox with everything hyphen. All right. While folks are still kind of wrapping up this step, I'll also say that there are 4 activities in this container for scientists workshop file. We'll only probably get to 1 or 2 today, but obviously I encourage you to try out the other ones on your own time and for sure send me feedback because I will be making this into a full course. And you are kind of piloting this for me. So any feedback you have about any of this that we covered today or any of the other extra stuff, that's super helpful for me to know. So, all right. I am going to continue on unless I see anyone tell me stop. All right. We'll also take a quick look at these files in here. There's obviously some instructions. You notice the 2, 3, and 4, I have Podman and Docker as one. But the first one, if you are Podman, you have to go to a different one because there's enough different steps that I couldn't make it one. It also has some mock files in here because we're going to pretend to do a containerized analysis. And so you'll see, again, I tried to follow what we talked about yesterday, having these scripts numbered, as well as there's a main script called runanalysis.sh where we can call that to run the whole thing. So that's kind of a little bit about what's in here. There's some additional things that just kind of help us housekeep and that you don't need to worry about so much, but I'm happy to talk about that in more in depth later. All right, I'm going to continue on. So hopefully we have our workshop file. So now I can close this GitHub page if you want to. I don't know about you all. I like having less tabs. It feels mentally nice to me. Okay, quick warning that the most common stumbling block in my mind, both for me and then other people I've worked with, are having an understanding that containers are isolated from your computer, okay? So if your computer has files or software or anything else, your container does not have it by default. It will not have what you have on your computer. That's the whole purpose of it, right? Is we're trying to like run kind of its own little computer inside there. So look out, we are going to encounter this. We are going to encounter this problem of it's a blessing, but it's a problem of having files and software that are on our computer, but not on our container. Okay. So just look out. Okay. That was activity 0. Now let's do activity 1, where we're going to pull and run a Docker image. So I am actually going to follow along. I'm going to make my text bigger so y'all can see. I'm going to follow along with you. All right. So we have installed Docker. I have created an account, so I'm going to check those. I have started up my Docker app, so I'm going to check that mark. Now I'm going to pull my Docker image. So pulling, what is pulling? If you're familiar with GitHub, this term is probably familiar to you, but if not, then it probably sounds strange. But pulling is really just meaning that we're going to take an image from online, okay? You currently do not have the container or image that we're going to use, but you're going to pull the image from online because that's what we told you is the perk about images is that they're easily shareable. So I'm going to copy this thing that says Docker pull cansav09. That's my old username, and I can't seem to change it to my new username. And then a practice image 1. Okay, so I'm going to copy this whole thing. I'm going to go to my terminal, So make sure I know we're getting more windows, so just try to keep them track. We got instructions and we got terminal, okay? So open up your terminal or command prompt and you're gonna paste that right in there, or we're gonna say Docker poll. And we're gonna be doing a similar thing at the end of all this to pull the Chime 2 image that we're gonna need. So it should spit out a bunch of like little key things. Clearly mine, I already have it, so it said it was super quick. Yours might take a little bit more time. So try to run this and we'll talk a little bit more about these images, okay? So Docker poll is what we're doing. I am going to, after I ran that and it did successfully, I'm gonna check this box so I can keep track of where I'm going. Okay. Are folks currently pulling this Docker image? Yes. Yes, we're pulling the image. Has it completed pulling or is it continuing to pull? It might take a few minutes. It usually tells you like a bunch of stuff while it's pulling. As it's pulling each like layer, they call it layers, by the way. There's a whole bunch of terminology. As it's pulling stuff, it'll tell you kind of stuff as how it's doing. But what you see when it's done is this. Now, remember, if you're following Podman, you're going to have to go to the Podman. You're in the Podman, hopefully, instructions, but you will find that really you're almost doing the exact same commands. Just replace Docker with Podman. But I do still recommend going to getting the Podman specific instructions. But I'm going through with Docker right now. Okay, but of course, when I switched, it got rid of my check marks, which is what it's supposed to do. But all right, so I've pulled my image. Have you pulled the image? We've pulled the image. We pulled the image. Okay, I'm not seeing any nods this way, so I'm going to keep going. All right, so there are different ways we can check what images we have. We can do it from command line using this called Docker image ls. You probably recognize that ls is what we learned at the command line thing, and we can also use it with Docker. So if I run, there we go. If I do Docker image ls, I can see it tells me, it spits back to me that same practice image thing. Tells me some other information about it, how big it is, when it was created, etc. All right, so Docker image ls. So if you do that, that's what you should get back, something like that. The image ID will be different, potentially, or maybe not. Container ID definitely will be. So we should see this show up in the output. So check that box if you see it show up in the output. Okay, now let's go back to the slides for a second. Okay, you can use Docker Desktop. That's what the slides show, by the way. But for the ease of like us all doing the same thing, I'm using command line. All right, so we already kind of prefaced this, but to really use our image, we have to make it into a container. So if an image is a snapshot of an environment that's easily shareable, a container is an environment that we can run stuff in. That is my very informal way of saying it. Like an environment, now we can play in there, all right? So we are going to do Docker run, and we're going to reference that same image name, Docker run. I'm going to go back to my terminal. I'm going to do Docker run, that image name, click enter. It should take a few minutes, and then it's going to also spit out a bunch of stuff. But at the end, it'll say starting service is done. Okay? So try to do that part. Have people successfully done Docker run? Hopefully we have a container. We have hopefully a bunch of containers. Okay? And to check if we have that container, I'm going to check that box. To check if we have that container, you might have to open up a new terminal window or command prompt window. But to check if we have a container, we're going to do Docker PS. So Docker PS lists what containers we have. Docker image ls lists our images. Docker PS lists our containers. So hopefully if we look at this, we'll see something like this where we have that image name. It tells us what image it came from. This container ID is going to be different for everybody. So don't worry that it's not the same. It tells us when we created it 32 seconds ago. And then it makes up a name for you. So that'll also be different for you, but you should have at least one container listed right now. Okay, so I'm going to check that, and you should see that same container. Do we all have that container? Yeah, I'm seeing yes nods, so I'm going to continue. Okay. So now, let's talk about, okay, great. Hey, we have a container. This is so exciting. But okay, now what? What do we actually do with this? Yep. Yep. Yeah. So Docker and or Podman have their own places where they're storing that. It's not going to be, you can have the actual image file, but you don't have to worry about working directory in when you're pulling the image, but that's a great question. Yep. All right, so let's talk about some examples of ways you could use your image Docker. We're only going to do some of these, but here's some ways you could do it. You could run a single command using your Docker container. Maybe you just want to run one thing. Maybe you want to run a whole script. You can also, for some images, you can port to a browser and just develop from there. I'll show you an image of what that looks like. And then this is a little more advanced, but if you want to use GitHub Actions or another app, you can run it all on the container. And that's actually why people really like containers, is because they can ship their apps very nicely. And it makes things like you notice with command line, how many times we had to be like, if you have this, if you have that, if you have this. Well, if you have a container, it's more reproducible, more stable, all of those things. Okay, so here's an example. This is actually how I really recommend people use containers if they're doing analyses, is you can run, you notice how these actually have these are from browsers, is because you can use Docker containers to open up a browser and you can just work from there. You can just work from, if you use RStudio or Jupyter, looks exactly the same. And actually with QIIME 2, we're going to do that too. So you'll exactly get to do that kind of experience. Okay, but the other way we could do it is we could just do command line from our container. Okay, so the way we're going to do that, so we can copy this, but we're going to have to replace this with what our container ID is. So actually what I'm actually going to do is copy the first part, where we're going to go to our terminal, docker exec -it. We're going to copy our container ID, copy that right in there, paste that right in there, and then we say bash. Okay, so docker exec -it, put your container image, because that's going to be different for everybody, and then put bash. Okay, I'm not going to click enter yet, but I want everyone to get to this point. This is in the new terminal. Just leave that other one go. Yes. Where you did Docker PS, go to that one. Keep that one handy. So have that up there. Yep. So for the particular image we have, it is like keeping that image open, like it's continuing to run or whatever. When we ran the container, it is an image that you can use a port from. And so sometimes it does that where it has the terminal open. Like I think sometimes you can shut the window and it'll be fine. Sometimes you can't, depending on how they made the image. But anyway, but yeah, so it spit out a bunch of stuff. We're going to see an example in a second of like how you can run a thing and then the container will automatically have a command it does. And that's kind of what this one is doing, but we haven't explained that yet. So I can see why that's confusing. Okay, how are we doing? Have we gotten to this point? If you've gotten to this point and you feel confident, you can click enter. And I'm going to actually click enter now, because what you should see is something like this that says root at, and then you'll notice that looks familiar, right? That's my container ID. And now it has a cursor, like it's waiting for me to say something. We have now entered our container and are working from our container. So have folks been able to use Docker exec? Anybody need help getting to this point? You need if you want to know how to do those things from actual Docker, the slides show that. I can also show you real quickly on here. I'm not going to click the buttons, but on Docker desktop, you can see that you wouldn't have to do the commands like Docker PS or Docker image ls because it shows and is actually keeping it up to date as I've been going along. So here I'm on the images tab. It shows me what image I have going on. I can go to the containers tab. It shows me that same information that we just saw for Docker PS. And I could click stop or run. Like I could click run here instead of doing Docker run. But yeah, because not everyone can install Docker Desktop, we're all just doing it from command line this time. But that is all in the slides if you wish to do it that way. Okay. All right. Does everyone get to this point? Docker exec, we have some kind of blinky thing with your root at container ID. Okay. All right. So now we can do our normal command line commands in here. So if I did ls, it shows me a bunch of folders that are in my container, which is interesting. And yeah, this is kind of cool. So why don't we try calling our script, right? Let's do bash run analysis.sh. You try doing that. And then you explain to me what's going on. Mine is saying no such file or directory. Why is this? We downloaded our workshop files and we're running a container. And any idea why can't it find the file? It could be that we didn't go to the right folder. But do we remember what we said about files on our computer and software on our computer is not the same as files and software on our container. Those are different things. They are isolated from each other. So if we want files to be on our container, we actually have to do a thing to get the files on our container. And that is where, okay, yeah, question, does our container have all the same files that our computer has? No, it does not. So that's why it leads us to our next activity, which is we got to add a volume. So a volume allows us to access files from our container that might be on our computer. So let's do that. So here's describing what a volume is. It's a folder that can be accessed by your container, and we can attach it, and that would be great. Actually, I should have put that over on the container part. I'll switch that. Okay, so it does show how you make a volume from Docker, but I'm going to do it from command line. I'm going back to our instructions. Okay, we did these steps where we tried to call a script. You can also do that all in one if you wanted to put the container ID and then just call the script from there. But you can also interactively, obviously, as we showed, like work from Docker container like that. Okay, so there's different ways we could get files onto our container. We could attach a volume, which is what we're going to do. The other way you could do it is you could just download stuff from the internet from your container and just like git clone or wget or curl. You could just download that. That's another way. But for this example, we're going to use volume. Okay. So to do a volume, we're going to do Docker run again. Okay. So we already have our image. We don't have to download the image again. That image is still there. We can make so many containers from the same image. It doesn't matter. It would eventually take up a lot of memory on your computer, but we could. So we're going to do this. We're going to do Docker run, and then we're going to use this -v option. Okay. And I'm going to show you a little bit of breakdown of what this looks like. So it's Docker run. You'd say -v, which is for volume. And then we say the folder on our computer. This is a file path that we want to be accessible with our files. And then we do colon. And then we do, where do we want these files to show up on our container? And then obviously, just like the other time we did Docker run, we have to say what the image is. Okay, so if we want to get our workshop files on our container, however, and we're going to use this print working directory, we need to navigate to our actual workshop files first then. So I'm back in here. You probably left off where you're still doing bash interactively from your container. To get out of here, I'm going to do exit. So type in exit if you are still in your bash container. And it should tell me, right? Like you can see the difference. Before it said I had this before. Now it tells me I'm back in my computer. I'm not doing commands from my container now. Okay, so I exited. And now I'm going to navigate to my workshop files. On my personal computer, I have them on my desktop. But you're going to need to know where they are on your computer, and we're going to use tabs right now. So I'm going to change my directory for me, I'm going to go to my desktop. And then I think I put my workshop files right on my desktop. I'm going to check for a second. Yep. And the workshop files are called Containers for Scientists, blah, blah, blah. You don't need to have that all memorized. I can just start writing contain and then just do tab. And then it's gotten it all written out for me. Okay. So I'm going to change my working directory to where my workshop files are. Once I think I'm there, I'm going to do ls, and it should give me something like this. Okay. So change your working directory to your workshop files. And when you do ls, it should look like this, where you can see the activity instructions. We saw those, right, when we looked at the files before, but now we're looking at it from command line. Okay. So change your working directory. Huh? Oh, yeah. If you hadn't gotten those files, then you wouldn't be able to navigate here. If you can't navigate there, we're going to have to figure out where did you put those files on your computer, and we can help you with that. It's probably in your downloads if you didn't move it. Also, make sure you've unzipped it. If you haven't unzipped it, then it also would tell you you wouldn't be able to get in there. Okay. How are we doing? Now we got this as our, yes. Okay. Anybody need help, or are we have this as our working directory? We see these files. We're good. Yes. You need help. Okay. Kate is coming to help you. Sometimes you have to give Docker permission to work with your files. So if it prompts you and says, hey, are you letting Docker have access to these? Say yes. That also could be a thing that pops up. Anybody else having this or similar problem? You have that problem? So that's the but you have the workshop files that we have in the Great. So go back to your yes, so download and then you there you go. And then you're going to do great. Then you do ls. Perfect. You're good. Okay. Anybody else had trouble navigating to their working directory? Yeah. So if the files were in your downloads, or not in your desktop, like I kind of have them by default, you would honestly, if I don't know where my working directory is, then I do ls, or again, you could do pwd. So I obviously know right now I'm going to open up a new, just to show this example, right? If but I'm keeping the other thing open because we're going to continue from there. All right. So if I didn't know where I was, I could do ls. And then if I knew my thing got my downloads, if I did ls and I saw downloads was in here, sometimes I even like go into my GUI, right? I could go here and kind of explore if I knew where a file was. That's another strategy is you could kind of use your GUI to figure out where the heck things are. But if I had in my downloads, then I could do ls to make sure downloads was something in my directory. If not, I might have to do cd ... right, to back up, to go to a parent directory. But then I could do cd downloads, and then if the workshop files were in there, then again I'd start to write containers. It is case sensitive. Recall that the command line and file paths, they are case sensitive, so you need to be careful about capitalization. And then I could do tab, but obviously, like, you might have a thing like this where it says, "Hey, it would like to access your downloads folder." And if you get that kind of thing, say, yeah, of course I want to be able to access my downloads folder. All right. So that's how I do it. But I don't have that file in there, so I can't really go there. Okay. Has everyone got to this point? We have this as our working directory. Great. So now we're actually going to run a Docker, but we're going to attach a volume so we can access those files. So we can do this where we see Docker run -v. You can copy this right as is and right there. Okay, it'll give you the same thing. This should start to look a little bit familiar. You've seen this crazy screen before where it spits out a bunch of stuff and says done. And we're going to, so if you've gotten that, what we should be able to do is take a new window and we're going to try to do the Docker exec thing. Again, we're going to repeat what we did before, basically. Yeah, I'm going to go to the, yeah, hold on. Let me go to I'm doing some window juggling myself. All right, so we're going to retry. So you should have this kind of window if you ran your thing but attached a volume. So just to recap, what I did here was Docker run -v. I copied that the command exactly. I did Docker run -v, and then it told me, it spit out a bunch of stuff again. Ignore all this stuff it's spitting out. Don't worry about that so much. I'm going to minimize that though. I don't need it right now. And I'm going to get a new, oh, not that many. Oh, I just clicked command N a bunch of times. I meant to zoom. Okay. So now I have a new window open and I can do Docker PS again to see. And now I should see I have two containers, right? We never did anything with our old container, so it didn't go anywhere. It's still there. We're going to cover how we delete those. But now we see we have two. So you're going to want to be careful that you pick the right one. You want to pick the most recent one, not the first one we did. So copy the container ID from the most recent. I see this one, it says about a minute ago. This one says 19 minutes ago. I don't want the 19 minutes ago. I want about a minute ago. So I'm going to copy that container ID. And we're doing the exact same thing we did before. But this time, the difference is we are hoping that we actually have the file. So Docker exec -it, paste in that container of your most recent container you ran. And then I could do this actually all in one. But I'll just do it interactively, I suppose. I'm going to do bash. And then same thing. This should start to look a little familiar. If I did ls, I should see some files. I should see a home folder. Okay, so have we gotten to this point where we have done Docker exec, but for our new container? No. Do we need help? Okay. We've found another Windows exception. If you have a thing where it says like invalid reference, I don't like this or whatever, what you need to do instead is put a $ curly brackets around PWD. So you need to put curly brackets around this thing. So it would look like this. I'm going to type it in here, but it's not going to look the same. It would look like this. I'm not going to run this because I'm in my container, but it would look like this where you have to change this to be curly, $ curly brackets, PWD, curly sign. So that's actually what you're going to need to do instead. Curly brackets, :/home. Okay. So if that is a problem you're encountering where it says something about like invalid reference, it doesn't like the $ PWD. And it seems like we're getting that a problem with Windows. That was what was happening here. Okay, great. See, and these are things that piloting is good, great to know. All right. That's fine. Yeah. So if you're Windows, the second part, so I didn't explain this part yet. Did people get this far where you're inside hopefully you have your container. So if you ran Docker PS, does everyone have their newest container? You should have 2 containers at this point. Yes? We're resolved mostly? Okay. So we're going to do the same thing where you do Docker exec -it container ID bash. Okay. So do that part. And then I'm going to talk a little bit about that volume specification. So do the Docker PS part and Docker exec. So this is what the file specification looks like for volumes. Is the first part, which now we know this is $ or the curly brackets. I'll put that on there. The first part is the folder you want on your computer. You do a colon. And then the second part is where you want those files on your container to show up. So in this case, we're saying /home. We want it to show up in that home folder. However, any idea why that wouldn't matter for whether you have Windows or Mac? So like, we talked about that Windows has to do backslash and Macs have to do /. Why wouldn't it matter this second part? Why is that the same for everybody? This is a tricky question. I'm being very tricky. Because this is specifying on the container, and the container has the same operating system for everybody. That's why we love containers. They're the same for everybody. So we don't have to change that part. However, we did have to change the first part because that part was operating system specific. Okay. Great. So I think hopefully we are to this point, and we're going to try to run this again. Okay. So I did Docker exec. I took my container, my most recent container. That's important. And did bash. And now I'm working with command line inside my container. And now if I, for example, change directory to home, because you see when I did ls, I can see I have a home folder. We just referenced that our files should be there. I changed my directory to home and I did ls again. I should see some familiar files. That is all our workshop files. So I should be able to see that. And now I should feel pretty confident that if I did bash run analysis.sh, again, I tabbed for that because I didn't want to type it out myself. Oh, it started to run some stuff. We have a different error. Isn't that a different error in programming is actually a success sometimes. And this is a purposeful error. And we'll talk about what this error is about in a second. Okay, did we all get this thing where we have a new error now? You don't see this part? No. So I'm going to ask the crowd, which is all you. What do we think this error is about? If you were to just guess, it says error in load namespace. There is no package called R Markdown. Why? What? I've installed R Markdown on my computer. Why would this error be telling me this? It's not in the container. Yes, exactly. So again, that's why I warned you that the most common pitfalls are, and because I think this is just how human brains work, is we want to think that, oh, well, I installed it on my computer. So nope, we need to have everything we need in the container itself, not necessarily on our computer, but in the container. All right, so now we have the files. So now what we would need to do, and we might not have time to finish this part, but we'll get started with it, is, again, does our container have the same software? No, it doesn't. And that's the beauty of it. We don't want it to have all the same stuff that our computer has. However, sometimes that means we have a package that we might need that we need to install. Okay, we're going to start the second activity. We probably won't have time to finish it, but it is here for your reference. So please go to this instruction. And this one is called, actually, I'm going to go to my other window. Other window over here. If I can open it. Yep, okay. I'm going to actually, and if you're already here, you don't even need to use that bit.ly link, by the way. You can go to the menu bar. You can go to modifying image, okay? We're going to start to talk about how to modify images, but we probably won't have time to do the whole activity, but I totally encourage you to look at this stuff on your own. Okay? So go to modifying images. And it should look like this, where we say build, modify a Docker/Podman image. So we're going to actually go to our file. Don't worry, but you can close your so many terminal windows right now. Close them all, doesn't matter. I'm going to go to the actual workshop files. Oh, that didn't really help. I'm going to open up a file. So in containers, you're going to go to your containers. This is just, we're just doing this in the GUI. No, we're just exploring here a little bit. We're going to open up the activity files. I'm going to open up the Docker file. You'll see 4 Docker files. 3 of them are labeled bad. That's for a different activity. Don't worry about that. Just open up the one that says Docker file. Yeah. I can't zoom the Finder, unfortunately, because it just makes the files big. And that was unfortunate. I know. So yeah, go here, open the Docker. It's in activity files. And then open the Docker file. And you can open that with any text editor. Doesn't matter which one. And it should look like this. Okay. So we're at this stage. Use any file editor to open up Docker file. So open up, it's in activity files and Docker file. Okay. Have we found this file and we opened it up somehow? Sorry, I can go back to this. This is in your workshop files. You go to activity files. It's the Docker file. There's 3 bad Docker files and 1 good one. Open up the good one. The bad Docker files are a tricky activity for later if you want to on your own. They all have a little bit something wrong with it, and you try to fix them. Anyway, that's on the number 4 activity. But we're not going to have time for that, obviously. Okay. So open up the Docker file. It should look like this. I'm going to talk a little bit about the contents of this Docker file, and then we'll build it. I don't think we'll have time to modify it, but we will build it. Okay. Let's talk about what a Docker file is. So if the image is something we pulled from the internet and the Docker run is how we made a container, then the Docker file is, I think of as like a recipe for how we make that image. Okay. It has step-by-step instructions where if we build it, a image will result from that Docker file. Okay. So, oh yeah, here, this is hopefully a little more zoomed up. It says about Docker files. So we're going to open up that one. Let's inspect what this Docker file looks like. So there are these all caps Docker file commands. One of them, you'll see two of them right here, but there's more of them. From and command. So from is a really important one because it allows us to use other people's images as our base image, right? Can you imagine how long it would take to like attach every single thing that we needed if we were building an image from scratch? It would be like impossible. It would take so long. So instead, what's really handy is we can use a different image, which we're using the one we already have, to start with, and then we can just add on more stuff to it. That's really handy because that means if you are trying to do something later on and you need a certain packages on there, you could probably find a reliable source that has that Docker image already and then just add any additional things you need. Because it's nicer to have a smaller, so on the very end of this, I also talk about what are the best practices. You want the smallest image you have that has everything you need. If you have a really big image, it can really be a headache to deal with. The other thing I'll say is that, maybe don't go download random developers files, but if you see that it's like a big developer, posit, Docker themselves, somebody from Ubuntu, or I don't know, whatever, like those are probably fine. Those are not going to be, but sometimes people do bad things. So we got to keep an eye out for that. You can also see from this file that the pound sign or hashtag is for comments. So that's going to be ignored. That's just documenting because we said documentation annotation is so good. And then lastly, we're doing a little command here. So what this will do is when we run the container, this thing will be run as well. We're just doing an echo. So it's nothing super crazy, but like you could make that into something else. All right. So that's what's in that Docker file. So let's just try to build it. Let's see if we can build it. That would be great. Again, if you have old terminal files like you just saw me open there, don't worry about that too much. Okay. One more time, we're going to have to navigate to our workshop files. We've done this a couple times, so hopefully we're getting quicker at it because it does take practice. A lot of this stuff takes practice. We're not expecting you to become a Docker expert just by an hour and a half. So I'm going to change into my current working directory is I'm going to change it to the workshop files. I just start use your tabs, changing into here. And I got to change one more time. I need actually my working directory to be activity files. Oop, see, and it told me, I don't know what that is. And that is fair because I spelled activity wrong. No, I didn't. There we go. I might have spelled the wrong word. Okay. So you should have your working directory be your workshop files, but within there, you want it to be the activity files. Okay. Activity files should be your working directory. I'm going to go back to the instructions. More window juggling. We are going to build an image from this Docker file. Granted, we could have used the -F option to tell it where to find the Docker file, but what we're doing here is this period here is just telling it, just build the Docker file you find in our current working directory. So that's another way you could do it. Sorry, let me make this bigger. Okay, so our current working directory is activity files. And then we're going to do, oop, not that. I'm going to copy this. I'm going to build from that. It shouldn't take very long because we have the base image already, but it should do a bunch of blue text at you. And Podman doesn't do blue text. I don't know what Podman does. It does a bunch of other output. But now we've built an image from scratch, which is great. But like, it still doesn't have that R markdown package that our error was based on. So what we're actually going to have to do is, so we did that. We could run the new image. And when we ran the image, I'm going to skip through this part so we can try to do the last part. Well, when we run that image, we should be able to see like it where the command part is going to actually spit out that little message that we had in there. So that's what command does. It runs the thing when you run the image, or sorry, yeah, turn the image into the container, run it, Docker run. Okay. And then what we would do, and I don't know if we have enough time to do the whole thing, but I'm going to set you on this anyway, is we would edit the Docker file so that it actually installs what we need, which is the R Markdown package. Okay. So I'm going to go back to my Docker file. I am going to delete the command line. Sorry, that's confusing. I'm going to delete the line that has the command part here. I'm going to paste that whole thing. So that command, don't try to write that command from scratch. That's not going to be very easy. I'm skipping down to step 7, edit the Docker file. Copy this whole thing that says run. So run is a thing that's going to run when you're actually building the image. And that's what we want it to do. When it's building the image, we want it to install this package we need. So I pasted that whole thing in this Docker file. A couple small comments about this. This is going to be something usually bash, right? Something bashy. So command line. I didn't really define what bash was, but it's when we're doing command line stuff, we're usually using bash. These backslashes just allow it to know, oh, that command's going to continue on the next line. So that's all the backslash is for. And then the rest of this is an R script because this is an R package we're actually installing. So don't worry about all the specifics of the R thing, but that's what it's going to look like. Have people edited their Docker file so it looks like this? Yeah, I'm seeing nods. Great. And so then we will go back and we're going to do the exact same thing. We're going to you can literally click up and have it repeat the Docker build. So I'm going to click up. I'm going to rebuild the Docker. This is going to take a little longer this time because we're actually doing something that's going to take a little more time. It's going to install that package. It's going to install all the other dependencies. This part is going to actually take a minute. We're not going to have the time to do the actual testing part, but what you should find. Oh, shoot. I forgot I was going to tell you to put a version tag because that's important. You shouldn't have listened to me. You should have listened to the instructions, which was to change the version tag. Versioning is important. And I just told you not the version. So that was on me. All right. So you can put version tags. So we had 1. We were going to change this to 2. Okay. Which would have been easier to keep track of, but that's okay. And then we would repeat the same steps we did before. We're not doing this. I'm just giving you a preview while your Docker image is building. And then what we should hopefully find is that the whole mock analysis will actually run and it'll make like a little cute HTML file for you. So you'd run the same steps. And so while this is building, I'll just tell you that in summary, basically, if you're missing files, add a volume. If you're missing software, add to the Docker file. And that's kind of your main, those are your main things that honestly, when you're getting a Docker image suited to your needs, that you're going to need to know about. Stay tuned for the full online course and feel free to engage with the other 2 activities in the website. We're obviously going to do more stuff with Docker, but with Chime later on. And the other thing I was going to say is some best practices. These are important. Do not put protected data on your image because people can get that. So that's very important. If you have any kind of protected data, PII, do not put that on there. Make sure you consult data privacy experts when needed. Try to not have super huge images. So sometimes I've seen people just continue to add to that same Docker file, but you can have as many Docker images as you want. So make more of them for specific use cases. And that way they're smaller and easier to download and easier to handle. Last thing I'll say too, before we're going to have you download a Chime 2 image we're going to use later, because that might take a little bit of time. So if we do that while we're eating lunch, hopefully we'll be ready for later. The last thing I'll say is now that we've done all this stuff, you will see you have a lot of images and containers. You're going to want to clean that up. because if you don't ever delete your stuff, then eventually this is using a lot of your memory in the background, and that'll be not great after a while. To do that, I have actually specific commands in the slides right here. Slide, what number is this? Slide 73. You can do the command lines there, or if you have Docker Desktop, you're going to need to get rid of the containers first. Okay, because if you have a running container that's using the image, it won't let you get rid of the image that it's using. So you got to get rid of the containers first and then get rid of the images. But that's just you should clean up so that way your computer isn't sounding like it's working super hard like mine is sounding right now. Cool. So then hopefully this is built. Did your image build? Now, it might take a little bit of time. What is the specific image that they need to pull? It's on the tutorial. Okay, so let me go back to the schedule. Okay. Go to that one. Working. Okay. So this one. This. Okay. So after your thing is done building, first of all, you can repeat those steps on your own, and it should actually have the software and the files you need. So you should be able to do the whole thing. So that's what's cool about what the steps we did. But you can let it continue to build. But once it's done building, last thing we'll do before we're kind of taking a break is you're going to do Docker image pull and this whole thing. So go to if you're in the schedule, go to the tutorial, click on there, and then pull that. If you already pulled it, you're good. You don't need to do this again. But if you haven't pulled it, try to pull it now because it might take a little bit of time and you'll need it for this afternoon. Okay? Yeah, you can do Docker image ls and see if you've pulled it. If you see it show up, then you know you have it and you're good. Don't do anything. And actually, even if you pulled it again, usually it tells you already existing and it'll just, re-pull it again. So, okay. Any wrapping up questions? Questions about Docker, questions about pulling this image, anything else? We also have lunch. You can talk over lunch. That's also good too. Yeah. Mhm. Yeah. Sounds great. You don't have it. Okay, we'll help you get it. Okay, great. Okay. Yeah. So that's all for this. I'm gonna stop recording. But yeah, if there's any other questions about Docker, obviously let's chat, Yeah. Yes. Yep. Put it right in there. Yeah, it doesn't matter where you come from. All right, and then I will. Yep.